Okay, we're growing. We have our mole, the measure of chemists, our convenient way of counting very, very large numbers of materials. We now also have our atomic mass or molar mass of any and every element on your periodic table, which means we can use that to change the measure of chemists, a mole, into an everyday mass, a number of grams. The problem with where we're at so far is, when you look around you, most materials don't happen to be nicely portioned out in moles. So we don't have 1 mole of this and 6 moles of that. We've got very strange or odd numbers. So what we're going to do in this topic is we're going to look at how we can take any random number of moles and turn it into the everyday measure of mass. Or take the everyday mass and turn it into the chemist measure, the measure of moles. And let's not understate the importance of being able to go from speaking chemist and talking about moles to the everyday and speaking about grams. I mean, think for a moment, outside of any scientific teaching, have you ever heard of this measure, the mole, before? It's not something that comes up commonly. It's such a large number, it has no real practical use in counting most things. Amusingly, I have seen it in just one place, and it did make me chuckle, and that is that there is a well-known sporting drink that you can buy, and on the nutritional information, they quote the quantity of some of the materials you find in the drink in millimoles. It makes me laugh, of course, because 9 out of 10 people who buy it probably haven't had formal chemistry teaching, so it will mean absolutely nothing to them. It's just a marketing thing to make it sound more scientific. So, each to their own. In any case, let's look at how we can change from mass to moles or moles back to mass. So what I'm going to do is expand your tool belt. So, going into a familiar setting here, you can see once again we've got a section of our tool belt that we're expanding. Over here, highlighted in yellow again, we've got our number of moles once again, the measure of chemists. And in this topic, we're going to move between our number of moles and everyday mass measured in grams. If I want to find the everyday mass given the number of moles, I can use this top equation here. The little m there stands for my mass in grams, and that will be equal to the number of moles in moles multiplied by, right, this capital M here is my molar mass, my atomic mass. That comes from the periodic table, and it's measured in grams per mole. So just mass equals number of moles times your molar mass. Hopefully a nice simple calculation. If we're going back the other way, if we want to go from the everyday grams into the chemist's measure of moles, we simply rearrange that equation and we end up with number of moles equals mass divided by molar mass. Just quickly before we have a go at those calculations for ourselves, just a quick note, if you're doing some extra reading, you will find that in some texts and documents, when people are talking about molar mass, they put a little r as a subscript after that capital M, the r standing for relative atomic mass or molar mass. They are talking about exactly the same value, and once again, you get that from your periodic table. It is that molar mass. Right, so let's have a look at a couple of examples together to make sure that we can do this effectively. First question I've got here, you can see in the bottom left corner of the slide, I've got a picture of it. If we measure out 0.890 moles of magnesium metal, what mass of magnesium do we have? What is that everyday measure? Well, if we turn to our tool belt and have a look, see what skills we've got. In particular, I'm focusing on the new part of our tool belt for today. You can see that if I want to go from chemist's measure of moles into the everyday measure of mass, we need to move from left to right on this diagram. That means I'm going to be using this equation here. Mass equals the number of moles times the molar mass of the element of the magnesium. So finishing off this example together, doing the maths, we take our number of moles, 0.890 moles, times the molar mass of our magnesium, down here off your periodic table, that's 24.31 grams. And when you pop that into your calculator, you should get 21.6 grams of magnesium. Not too bad. Let's try another example, but this time we're going to go backwards. We're going to go the other way. In this question, how many moles of mercury atoms are present if I have 4.50 grams of mercury? Got to have a quick aside here. I've got a picture of mercury down the bottom there for you. Very cool to see. It's one of the few metals that's a liquid at room temperature. Getting back to the question at hand, once again, when we have a look at our tool belt, this time we have the mass already and we want to move back to the chemist's measure. We want to go back to moles. Moving the other way on the diagram, that means we need the bottom equation. Number of moles equals your mass divided by your molar mass. So once again, crunching the numbers, the number of moles will be equal to my mass, 4.50 divided by the molar mass of mercury, 200.6, And that gives us 0.0224 moles. Right, that'll do us for this topic. We now have the ability to take any quantity of material around us, any mass, and turn it into a number of moles, measure of chemists. Or if someone gives us a quantity of material, a fixed number of moles, we can tell you what that is as a mass, as an everyday measure in grams. In the next topic, we'll start looking at compounds.